Once you get your new PC up and running, you should always make sure that your components are working as they should and none of them are defective. Let's go through that process. The process we're about to go through is called stress testing, and it is the important last step of finalizing any custom PC build. Let's get into the first step, and that's stress testing the CPU. I use a free program called Cinebench R23 that runs a very intensive set of instructions against the CPU and renders a scene in a loop. Cinebench is gonna max out all of the cores in your CPU, and that's gonna bring any instability or problems with your CPU or other components to light. So the best way to run this test is to leave all of your system settings to their default. So that means BIOS settings and operating system settings. This is gonna get a baseline on what your system should do out of the box. If it's not able to perform on these default settings, that means that you truly do have stability issues or possibly defective components. So here we are in Cinebench, and I'm gonna go ahead and hit File, Advanced Benchmark, and then I'm gonna turn the minimum test duration to 30 minutes, and I'm gonna launch the CPU multi-core test, and I'm gonna pull up CPU ID hardware monitor, and we're just going to monitor all of the temperatures and all of the clocks while this is running to make sure that we're looking good and everything is within temperature limits and our frequencies are staying where they should be. We're 10 minutes into the test now, and you can see all of our P cores are still running at 5.5 gigahertz. Our E cores are at 4.3 gigahertz. And these two processing cores here have hit 100 Celsius each, which is resulting in the package reading 100 Celsius. But we can tell that these two cores are the most used, the most powerful, and the most efficient cores. And this is not to be concerned. The rest of these cores are holding steady in the high 80s, low 90s. So we can easily fix this with a little bit of undervolting in the future. These motherboards love to push a lot of voltage when it's not necessary. So we can adjust some of those voltages to bring these temperatures down while still getting these 5.5 gigahertz speed on the processing cores and lowering temperatures. Here we're 20 minutes into the test, 10 minutes to go, and we're still running at 5.5 gigahertz on all of the P cores. It does vary just a little bit. Again, we're only seeing 100 Celsius on these two cores intermittently. The rest of these cores are staying steady and working very well. The E cores are doing well. All the E core frequencies are 4.3 gigahertz. So things are looking really good for this test. So we're coming up on the end of the test, and we're still running at roughly 5.5 gigahertz. Our temperatures are still all looking really good with just these two P cores hitting 100 Celsius randomly. That's making the package temperature hit 100 Celsius. Nothing to worry about there. These processors are good. At least Intel 13900K is good till 105 Celsius. Cooling solution is working well. All of our cores have performed very well. None of the usages have dropped. The temperatures all look really good. So with that, we can conclude that our cooler mounting is good. Our cooling solution is appropriate for this processor. And I'm gonna be guessing our score is gonna be anywhere from 37, 37.5, something like that. But based off of these processor speeds I'm seeing here, that's where I think this processor will probably fall. That's very average for the 13900K. So our score is 37,564. Exactly where I thought it was gonna land. Everything's looking really good for this processor. Our temperatures have immediately dropped down to 30 Celsius. Our package is 36 Celsius. This test is concluding that this CPU is good to go. It hit the score it's supposed to hit. The cooling solution works, and all of the core frequencies are as they're supposed to be. Once you get done completing a 30-minute test in Cinebench R23 with no thermal throttling and no crashes, you can conclude that your CPU is working as it should. The next stability test is one that focuses on the graphics card. The first step to this process is to stress your GPU through a program, and I like to use Heaven Unigine. I'll launch Heaven and I'll let it run for about 30 minutes looking for for any issues with core frequencies, any crashes, or any type of temperature problems that may be occurring. Again, leave everything on your GPU stock so that you can see how it performs out of the box. 10 minutes into this test and everything is looking good. As you can see, all these graphs are very stable, which is excellent. Our GPU temperature is in the mid 40s. Our GPU clock is running at 2805 megahertz, which is excellent. Our memory clock is 10,502 megahertz. Everything is looking great. So we're 20 minutes into the test and we're not seeing any type of issue so far. The GPU clock is still running as it should. The memory clock is running perfectly. No glitches that I've seen. The temperatures are still the same in the mid 40s, so this cooling solution is working excellent. Very, very happy with the results of this test so far. Just hit 30 minutes on this test. Everything is holding steady, no glitches, no crashes, nothing. This test is successfully concluded. Everything is working very well. The temperatures are wildly low at 42 Celsius right now for the GPU, 46 Celsius for the CPU. Excellent temperatures. This has been an excellent test, excellent results. If you've looped Heaven for 30 minutes and you're not seeing any crashes, your core clocks look great, your memory clock speeds are where they should be, and temperatures are staying steady, you can conclude that your GPU is stable and working as it should. So the second step to this is booting up your favorite game and just playing that for a while. Make sure you're getting the frames per second that you're expecting, and just make sure that the game is running stably. Now, not all games are completely stable and you may experience crashes. So if Heaven was running well, you can conclude that it is most likely an issue with the game and not your GPU. Sometimes it may be a very strange issue tied to your GPU, but that would require further investigation. I wouldn't worry about game crashes unless they are frequent and they occur in a very repeatable fashion. Once you're done testing the CPU and GPU through those two programs and the game of your choice, we can now check the RAM and make sure that it is operating as it should. I use memtest 86 and I just set up a test to run overnight, and when I wake up in the morning, I just check the results. You don't have to monitor this test for anything. All of the results will be provided to you in a nice report at the end. This is a simple pass or fail test and is the easiest of all the tests that we have. You're finished. You've just finalized your PC build, and you can move on to customizing the user experience just how you like it. If you're wondering what software I use to monitor all of the information that I was looking at, go ahead and click here to find out.